guys, natural log. This is what we're going to talk about. We're going to do everything with natural log that we did with the other logs. The only difference is with natural log, you use base E, and it's written a little weird. So instead of seeing log base E of x, they have given it the shorthand notation of ln of x, or natural log. So this is where I found the inverse. Just like we found the inverse in the previous lessons, you change f of x to y, switch x and y, and then write it in log form, and then go back and put in your f inverse notation. E is actually kind of like pi. It occurred so often that it got its own special notation. So like pi is 3.14, E is 2.7182, and it keeps going. A lot of times you'll see natural logs used in chemistry, biology, physics, banking, and statistics. So the first thing we're going to do is practice writing between the exponential and log form, which that's what we just talked about when we were solving the equations in lesson 4. So this is kind of a review of everything that we've been doing since lesson 2. All right, so practicing writing in log form. So x, or 7 to the x equals 49. 7 is the base, so that would be log base 7 of 49 equals x. And I'm going to leave those two for you to practice. That'll be good review. You can check to see if you do those correctly by looking at the completed notes. And when you see base E, just like you saw base 7 and you use log base 7, when you see base E, you're going to use natural log of 15 equals x. So when you see base E, that's natural log of 7 equals the exponent. So you can try to do 6 and then go check your answer in the completed notes. All right, so going from exponential form to log form. Now we're going to go back from log form to exponential form. So just like this is the base, you would write 2 to the 7th equals 128. Here, when you see natural log, you've got to know that the base is E, so that would be E to the 6 equals 3x. So here you see that this is natural log of x equals negative 2, so that would be E to the negative 2 equals x. So leaving you 3 problems, you can try to work those and then check your answers in the completed notes. I mean, that's what we did in class, was I did one and then you practice doing some. That's how you learn, is by doing. All right. Then the properties of logarithms that we did in lesson 3, same thing applies with natural logs. This is the single condensed side, and we're going to expand it. So the product property, we use addition to expand. So the natural log of 2 times x expanded would be the natural log of 2 plus the natural log of x. And then expanding the natural log of x divided by y, that's the quotient property. That is with subtraction, so natural log of x minus natural log of y. And then this is the power property, where that exponent becomes the coefficient. So natural log of x squared becomes 2 times the natural log of x. So this is going from the single log to the expanded side. And then here's some examples where we're going to condense. If we want to write this as a single log, we see that it has the plus, so it's the product property, so that would become the natural log of 4 times x. This has got subtraction, that's the quotient property. This would become the natural log of x over 7, or x divided by 7. This one has 2, so we've got to first move 3 to become the exponent, so that's your power property, so that becomes natural log of x plus natural log of y to the 3rd. And then to put these together with the plus, that is the product property, so that would become the natural log of x times y to the 3rd. And this one is reviewing to see if you remember what the 1/2 power means. So that's going to become the natural log of x to the 1/2 power. That's your power property. And then do you remember what that 1/2 power does? So if you had typed in 49 to the 1/2 on your calculator, the last time I did this in a lesson, if you watched them, I know you know what I'm talking about. You would get 7. Well, that means the same thing as taking the square root of 49, which is also 7. So this is probably going to be written as natural log of the square root of x. Using some of the other properties, the inverse properties, the logarithm of 1, these are the review problems. So if you saw log base 2 of 2, that would cancel and you'd have 1. This would cancel, you'd have 3. 3 to the log base 3, that would cancel in 7. And these are just the same. If you have natural log of e, those bases are the same. They cancel, you get 4. This is going to be 1. That's that special property. So that's 1. It's like the inverse, but they gave it its special name. E to the natural log of 7. So e and natural log are inverses, so they cancel. And then you can try these. Well, we'll do log base 5 of 1. Any log base of anything of 1 is 0. So natural log of 1 would be 0. All right, now we're going to look at how to solve some of these. So it's getting close to 7, so I've got to quickly finish this up so I can get these uploaded into YouTube and then on Schoology for some of you guys that are behind. I'm not going to show you both ways to do this. I think in class it confused some, so I'm just going to do one way. If you have e to the 2x equals 12, we're just going to do what we did before. We're just going to write it in log form. If you want to do this, you can go look at the completed notes. So if this is isolated, so you would write in log form. And you know e, the log that goes with e is natural log of 12 is equal to 2 times x. And then you would just divide by 2. So x is equal to the natural log of 12 divided by 2. So that would be your exact answer. If you type it on the calculator, you would get 1.242. And I encourage you to type it on the calculator and make sure you're getting the same thing I'm getting. So let's go to number 28. I have e to the x minus 2 equals 12. It's an exponential equation because x is the exponent. So I have to write in log form. So that the log that goes with e would be natural log of 12 equals x minus 2. So to solve, you're going to add 2 to both sides. So the exact answer would be natural log of 12 plus 2 equals x. And I encourage you to go type that in your calculator. This is your exact answer. And make sure that you are getting, let's see, I think that is 4.485. Make sure you're typing these in correctly. And I'll leave some of these for you to work because you need to practice and make sure that you can do these. So look at the blank notes, look at the completed notes. They're there for a reason. Because in class, I would work 1, you would work 1. In number 31, the exponential part is not isolated, so we would have to subtract 5 first. So you get e to the 3x equals 10. Now that this is by itself, we're going to write it in log form. The log that goes with e would be natural log of 10 equals 3 times x divided by 3. And x is equal to the natural log of 10 divided by 3. That is your exact answer. And then if you type that in your calculator, you're going to get 0.768. So I encourage you to work some of these that I'm not working and look at the completed notes. Please, please, please. That's what the notes are for. Number 34, you have 2 times the natural log, so this is not isolated. So you have to divide by 2. So now you have natural log of x is equal to 2. So now this is isolated. You can write in exponential form. The base that goes with log is e. So base 2 equals x. And all you have to do is find your e to your x button on your calculator and put in 2. And you should get 7.389. So this group, 32, 33, 34, 35, are log equations. So number 34 is a log equation. This is isolated, so I'm going to rewrite it in exponential form, which means the base with natural log is e, so that's the base I'm going to use. E to the second equals x minus 7. Then add 7 to both sides. And you get x is equal to e squared plus 7. That would be an exact answer. And if you type that in your calculator, you should get 14.389. Again, try these. You can you can do 2 tabs on your Chromebooks. You can look at the blank notes and the completed notes, and you can try to practice and follow along. The completed notes, of course, do look better. All right, so I finished this up in class today because nobody reminded me that I did not finish it the other day. So this was from second block. So completed continuously, it's an interest formula. So you can see how I've labeled everything. I think the completed notes online look a little bit better. I think I used fourth blocks. I was able to finish with those guys because of we're having advisory right now. So there is what everything stands for. A is the amount in the account after it's compounded so many years continuously, and that's big, continuously. P is your initial amount. That's your principal. That's what you're putting in. Your interest rate, of course, is R. It has to be in decimal form. T is the number of years. E is not a variable. Remember, E is that value, 2.718, just like pi is 3.14. All right, so when you're doing a problem on the test or in the review, if it says anything about continuously compounded, then you should be using A equals P times R to the T power, RT power. So I nicknamed that PERT just as an easy way to try to remember it. So we're looking for the amount in the account after 2 years. Let's see, the amount would be $1,000. E, remember, is E. And then R is an interest rate that has to be in decimal form, so 0.048, and the number of years is 2. So I'm just going to put parentheses like that. And you would type that in your calculator, and you would get A equals $1,100.76. So you can do 38. Basically, this is just substituting in for variables and typing stuff in your calculator. But the key thing is continuously is PERT. A equals P times E to the RT power. And then here was a challenge problem that I gave you. So the fact that it says continuously means that I'm going to use A equals P times E to the RT power. You've deposited $500 in the account, so that is P. Remember, E is E. It's not a variable. The interest rate, it's paying 6.75%, so that would be 0.675. And it wants to know how long, so that means I'm looking for T, for the money to double. So what's going to be in the account if the money is doubling? Well, if you're putting in 500, double means 1,000. So why don't you see if you can finish it from there, at least attempt it, because if you don't try to do problems on your own, then you're never going to be able to start some of the problems on your own. You can go back and look at the completed notes and see how I finished working the problem and check to see if you got it correctly. So there is Unit 6, really fast. I know it wasn't perfect, but from 6 a.m. to 7 a.m. in the morning, I think I kind of got it covered, I hope. Make sure you do all the assignments. You have 3 attempts on all the assignments, and tests will be coming soon.